Hello everyone, welcome back to the Lift Parts Warehouse channel. In today's video, we're breaking down one of the most important systems inside any forklift, the hydraulic system. If you've ever wondered how a forklift can lift thousands of pounds, tilt a heavy load back for stability, and place it exactly where you want it, all with just a pull of a lever, the answer is hydraulics. By the end of this video, you'll understand precisely how hydraulic pressure is created, how it travels through the forklift, and how it controls every major movement of the mast. Whether you're an operator, a mechanic, or you're just curious about the engineering behind forklifts, this breakdown will give you a clear, easy-to-follow look at what's happening with your forklift's hydraulic system. Before we dive into the forklift's hydraulic system components, let's quickly cover the basic science that makes all of this possible, Pascal's principle, which states, a change in pressure at any point in an enclosed, incompressible fluid at rest is transmitted equally and undiminished to all points in all directions throughout the fluid, and the force due to the pressure acts at right angles to the enclosing walls. This gives hydraulic machines a massive advantage. You can apply a small amount of force at one point and force out at another point. Imagine two pistons connected to the same sealed chamber of hydraulic fluid. The first piston is small. The second piston is much larger. When you push down on the small piston, you're creating pressure in the hydraulic fluid. Since fluid doesn't compress, that pressure travels through the system equally in every direction. Now here's the key. Pressure stays the same, but force depends on surface area. So when that same pressure acts on a larger piston, it has a larger surface to push on, which multiplies the output force. In simple terms, a small input force on a small piston turns into a much bigger force on a larger piston, all because hydraulic systems trade distance for strength. This is the core principle that every lift, tilt, and side shift function in a forklift is built on. That's the core idea behind every hydraulic system, from car jacks to pallet jacks, and especially forklifts. Now that we understand the basic science behind hydraulics, let's break down the actual hydraulic system components inside a forklift. These parts work together to lift, tilt, and control thousands of pounds with precision. The number one is a hydraulic pump. The hydraulic pump keeps the whole system alive. It pulls hydraulic oil from the tank through its suction port and pushes that oil into the hydraulic lines. On its own, the pump only creates flow, which goes from low pressure to high pressure area, initiating the pressure, but actual pressure is created later, when that flow meets resistance, like when you lift a load or tilt the mast forward. Most forklifts drive the pump directly off the engine or electric motor, and when the operator moves a control lever, the hydraulic control valve directs the flowing oil to the appropriate function, lift, tilt, or side shift, depending on what you're using. Then comes the control valves. Control valves decide where the hydraulic fluid goes. When the operator pulls a lever, one of these valves opens. Pressurized fluid is routed to a specific cylinder, which then moves accordingly. Lift, tilt, or side shift. It all depends on which valve is opened and how much. Next is the hydraulic fluid. Hydraulic fluid is the medium that carries pressure through the entire system. It's a specially formulated oil that does three important jobs: transmits pressure, lubricates moving components, cools the system. The next component is hydraulic cylinders. These are the parts that actually move. Hydraulic cylinders convert fluid pressure into physical motion. Forklifts typically have lift cylinders, raise and lower the mast, tilt cylinders, tilt the mast forward or back, side shift or attachment cylinders for steering forks side to side, clamps, rotators, etc. When high-pressure fluid enters the cylinder, a piston inside each hydraulic cylinder is connected to a rod. When pressurized fluid enters the cylinder, it exerts a direct force on the piston surface. That force extends or retracts the rod, which is what actually creates the lifting, tilting, or side shift movement on the forklift. We also have a hydraulic reservoir or tank, which stores extra fluid for the system and allows the oil to cool and de-air as it circulates. There are hydraulic hoses and steel lines that move pressurized fluid between components. They're built to handle high pressure, which is why regular inspection for wear or leaks is essential. Now that we understand the basics, let's walk through the entire hydraulic cycle from start to finish, from the moment the operator moves the lever. When the engine starts, the hydraulic pump begins pulling oil from the reservoir. The oil moves through the suction line, through the pump gears, and out toward the control valve block. At this point, none of the hydraulic levers are being touched, so the oil has nowhere to build pressure. Instead, it simply flows through the valve block and returns to the tank in a low-pressure loop, waiting for the operator to make a command. This changes the moment the operator pulls the lift lever. Inside the control valve, a spool slides into a new position. That movement closes the return path and opens a dedicated channel that directs pump flow toward the lift cylinder inlet port. Now the oil travels through the high-pressure steel line and enters the bottom chamber of the lift cylinder. Inside every hydraulic cylinder,
There's a piston sealed tightly inside a smooth, honed tube. A piston rod is attached to the piston and runs out through the front cap of the cylinder.
Hydraulic oil enters the lower chamber and pushes on the full surface area of the piston. Because hydraulic oil is pressurized and incompressible, it forces the piston upward. As the piston moves, it carries the rod upward with it.
The cylinder's front cap has seals that allow the rod to slide out while keeping all fluid trapped inside. The rear cap seals the back of the tube so pressure doesn't escape.
As the piston and rod extend upward, they either directly push the inner mast rails or pull the lift chains around the mast sheaths, which multiplies the lifting height far beyond the cylinder's own stroke. This is what makes the carriage and forks rise smoothly along the mast. When the operator releases the lift lever, the valve spool returns to neutral. This blocks the flow path and traps the pressurized oil inside the lift cylinder. Because the piston is sealed and hydraulic oil cannot compress, the piston and rod freeze in place, holding the forks and load at that exact height with no drift.
To lower the load, the operator pushes the lever forward. The spool shifts again and opens a return path back to the reservoir. The oil inside the bottom chamber of the cylinder now flows backward through the valve block and through a built-in flow regulator. This regulator slows the oil leaving the cylinder so the mast doesn't drop too quickly.
As oil exits the chamber, the piston moves downward, the rod retracts into the cylinder, and gravity brings the mast and forks down in a smooth, controlled motion.
And that's the full hydraulic lifting cycle, from low-pressure circulation to directing flow into the lift cylinder, to the piston and rod converting that pressure into upward motion, and finally a controlled return as the forks come back down. Every lift on a forklift follows this exact sequence.
Now let's look at what happens when you use lift and tilt at the same time, because this is where the hydraulic system really shows how smart it is. When the operator pulls two levers together, say lift and tilt, the hydraulic valve block decides how to split the pump's flow. On most forklifts, the lift circuit gets priority, so even if you're tilting the mast, the system makes sure the lift cylinders still get the pressure they need to keep raising the forks. At the same time, the control valve sends a portion of that flow to the tilt cylinders. They won't move quite as fast as they would on their own, but they stay smooth and responsive. No jerking, no sudden drops. This is why operators can raise a pallet and tilt it back at the same time without the truck feeling unstable. The hydraulics balance both motions, so the mast stays controlled and the load stays steady. And that wraps up our deep dive into how a forklift's hydraulic system really works. If you're responsible for operating or maintaining these machines, maintain consistent inspection schedules, watch for early symptoms, and never ignore hydraulic issues. A small leak or weak seal can turn into a major failure fast. And when it's time to replace parts, whether it's cylinders, hydraulic hoses, control valves, lift pumps, seal kits, or even complete assemblies, make sure you're using parts you can trust. Lift Parts Warehouse carries OEM-grade hydraulic system components for almost every major forklift brand. Fast shipping, quality parts, and support and warranty you can count on. Visit liftpartswarehouse.com to get the hydraulic parts you need and keep your forklifts running safely and at full power.